I'm Rochdi from Morocco, and today I'm going to share with you my little experience with Rasa. So it's a part of my software engineering internship at Changeable AI. And today I'm going to share with you, I'm still learning more about this framework, of course, but I will give you just, a little overview, about this I could say interesting chatbot framework. So I'm an open source contributor to Curry. So it's another chatbot framework. But today I'll talk just about Rasa, and I'll give you a little bit some good ideas about this framework. So as you know, Rasa is an open source chatbot framework to create and automate conversational applications. It provides several features to, help you efficiently develop your bot. So as you know, in the background, Rasa has two, libraries that operates with. So we have Rasa NLU and Rasa Core. So Rasa NLU performs the natural language understanding of the framework, while Rasa Core is the engine of the framework. It executes the action needed to send the appropriate message to the user. So here the story begins when the user send an input to the bot. So here what happens, Rasa NLU comes to create, or let's say to interpret the user input or the user utterance and classify particular information in some specific categories. Then Rasa Core comes to execute, as I said before, the action needed. But the most important thing Rasa Core does is manage the conversation state using the following parameters you see here. So the first one called tracker, and as the name suggests, it tracks or it keeps the conversation on track, save it in memory. While policy is the decision maker of the framework. It decides on what the action the bot should take at every step in the conversation. Then the last step we have is the featureizer, and this is getting help from the tracker, and it creates the vector representation of the current conversation state, so that the action later can create a tracker instance after every interaction with the bot. So although Rasa can participate in a dialogue if I said that, but it just doesn't use dialogue trees. So the most interesting point about Rasa is one of the most interesting concepts in computer science called FSM, and that concept stands for finite state machine. So what this concept said is FSM in general is a computational model that consists of one or more states. It can be only in one single state at a time, and each input to that state can cause, or can change that state to another one. And each state in this model or in this computational model can have, rules that determines which state to switch to. So here I'm trying to give a little example of a light bulb. This one is an FSM of light bulb. So here you can see we have two states. The light bulb is going to be whether, turned on or turned off. So if we, press or if we turn on the light bulb, that will make a transition to another state called off, which will turn off the bulb, and vice versa will happen. So that means on state defines, the rule that the state that you will switch to, which is off, and off as well defines the state that you will switch to, which is on. In other words, if we press on, and if we are in state on and we press, the on button, for example, that would change nothing. We will keep running on the same state. But if we push off the off state or the off button, that will switch us to another state called off, which will turn off the bulb. I hope that is simple, but that's all about the FSM principle. So the most important part, of building a bot is the process, or, is data in general. So it's the process of collecting data so the bot can learn from and recognize, user inputs. So in Rasa, we have different types of, learning data. So we have training data can have, some different type level keys that vary in terms of structure and functionality. So I'm going to share with you some of these top level keys, and one of the most important one in Rasa training data called NLU. It stands just for Natural Language Understanding, and NLU is the skeleton of the training data in Rasa. It creates, the training data. It is where you can, give examples of user utterances. As seen on this example here, you can see I define my NLU here, the top level key, and here's some user utterances. Hello, what's up, hey there. So I choose here this user utterances to greet the user. And you can see here, all these utterances are categorized into a category called intent. And this intent has a name. Of course, you can give it any name you want, but it's preferable to have a name that match, what the user wants to accomplish with that intent. As I said earlier, this will greet the user. So that's why I call it greeting. Another top level key in training data is called stories. And stories in general, it creates the conversation flow between the user and the bot. And it also create, the steps of the entire interactions. You can see here stories top level key and the first story here, but stories can have many stories and each story have steps. And steps here defines, intent, action, and so on. So intent here defines the user utterances. It just, the identification put in our training data as we showed you before. And here is our intent grading. But the new thing that we don't see before is action. And action represents responses of the bot. So here we can automate these responses in another top level key called responses. Here where you can put examples of bot responses to that specific intent. As you can see here, in order to create responses in the training data, you should always start with author underscore, and then you can give a name of the intent. But it's not necessary to have the same name, but just to keep, to map your training data very well, it's better to have the same name you give to the intent to the name of the response as well. So here is some example of text, but here I use something new. It's called button because I want to interact with the user. I don't want him to give him freedom to type anything. So I just put, button that will let user choose whether it's good or not. And that's it. So that's for the stories. Another usage of NLU is to extract information from user input or user utterances. So here we are talking about entities. And as Elianulua mentioned, entities belongs to a great, area of research in NLP called named entity recognition, or NER. So in Rasa, okay, we have the same concept. Entities are structured pieces of information that can be extracted from user utterances. So we can use entities, for example, to extract information like, name, like age, like, credit card number, in order to use it later in the conversation. So here I give a little example. So I want to book a flight to Casablanca, for example, and I want my bot, understand that Casablanca is a destination. So here it would be better for your bot to know which text text inside this intent refers to a destination. So here, how you can define a destination and an entity in your NLU training data. So you can see here, my bot can understand that Casablanca is an entity, and he can use it later, in the conversation in general. So entities also can be extracted in different ways, not only using NLU, but we can use something called synonyms, lookup tables, regular expressions, which I talk about, later in this presentation. So I will leave the link to the blog where you can find this. Right. So another usage of here is not okay. I think I talked about this anyway. So here I should mention something very important in Rasa framework is session maker that I mentioned before in the first slides. Rasa policies, as I said, are the session makers of the framework. It decides on what the action the bot should take with confidence level. So with a particular confidence level in general. So the policy that has the highest confidence level, it will decide on the action. So in Rasa, we have two types of policies. We have the machine learning ones and the rule-based policies. So the machine learning one consists of TED policy. TED policy is a transformer transformer embedding architecture policy that predicts the next action and other entity recognition tasks based on transformer encoders. And then we have another one called unexpected TED intent policy. This one is an auxiliary that you can add as well to TED policy in order to tackle and handle the unexpected user utterances. On the other hand, we have memoization policy, and memoization policy it compares the conversation stage with the stories available in the training data, so that if there is a match in general, so if the story calls this mentioned in the training data, we will get the highest or sorry, the policy will predict the next stage with high confidence level. The same applies to the augmented memoization policy. It looks similar to memoization policy, but it also, yes, it also learns from stories like the memoization one, but there's something special about augmented memoization. It uses another parameter called forgetting, and forgetting is very useful for augmented memoization because it helps this algorithm to reduce the search space while comparing the conversation stage with the available stories in the training data. When it comes to the rule-based policies, so we have only one in Rasa called rule policy. It's a fixed behavior policy that depends on the scenarios you trained them in order to predict the next action and other text recognition tasks. So another thing to mention, machine learning policies and rule-based policies can be used together, right? So in order to predict the next action. So additionally, it has some other useful features that can help you, evaluate your bot and maybe improve as well the bot's performance. So one of these features is tracker store, and tracker store in general is the parameter behind, or let's say it's the feature behind the parameter of tracker we talked about in the first slide. So tracker store, it keeps the conversation on track. It saves it in memory or in SQL database. Also, we have another useful features called markers. It marks the point of interest in your conversation dialogue so that you can use it later to evaluate your bots. However, Rasa has some problems in some advanced features. And here, I mean entity extractions features. So if I talk about lookup table, regular expressions, those features are great to fill forms, to extract information from user messages, but are not designed to create, make an FLs or just make in general the FLs decisions in order to create forks in your conversation design. And another thing, intents in Rasa are callable at all times. And the most funny thing in Rasa, checkpoints feature. So checkpoints in general reduce, you can use them to reduce repetitivity of your data in your training or in your NLU file. So instead of having stories, actions, stories, actions, stories, actions, so on, you can use checkpoints to reduce this frequency and keep things more simple. But if you overuse checkpoints and you use them too much, you can have some redundancy and confusion, and your bot can mess everything up. It means he can give you inappropriate responses to the input messages. So I hope that can be useful for you guys to understand a little bit how Rasa is used for. And so I put here some references. So this presentation is related to a blog post I wrote for proai.org. Here you can see any concept I talk about here in details. So also I have some blog posts, practical blog posts on how to create your Rasa chatbot. And here's some resources I used in order to, understand, some concept like NER and, NLP in general. So I hope that lightning talk is useful. Thanks for listening. Thank you.
Thank you. Any questions before we move on to our last speaker?
Thanks, Rochdi. So what did you mean by the title, The Trees Without the Trees?
Yeah, Rasa Dialog trees, yes. So it means with Rasa, you can, you can design your own conversation without using trees. So I think it's very simple, yes. So there's no need for trees to design your own conversation. So Rasa can participate in that dialogue, yes, without any concept, without any tree in general.